Alright, hello everyone. Today we're going to be doing another quick problem, letter combinations of a phone number. It's apparently today's Leetcode question of the day. It's a medium. I thought I would be able to do it. So, okay, no, sorry. I've done this before in previous, what is it? I guess Leetcode grinding sessions, but saw it was today's problem, so decided, might as well give a shot at it again. And I did verify right before this that I can make it work. So yeah. Anyways, let's get into the problem. Given a string containing digits from 2 to 9 inclusive, return all possible letter combinations that the letter could represent. Return the answer in any order. A mapping of digits to letters, just like on the telephone buttons, is given below. Note that 1 does not map to any letters. So for anyone that was born probably before like 2005, probably has used a phone that uses these numbers to text someone. If not, yeah, I guess. Anyways, might have just dated myself a little bit, but I mean before '05 isn't that telling, so it is what it is. It's okay. Anyways, so with digits 2, 3, we can have a combination of AD, AE, AF, BD, BE, BF, CD, CE, CF. Because all the 2 can be A, B, or C, and 3 can be D, E, F. So any permutation of that. Right, so what we're going to do is create a mapping first. So we're going to create a dictionary or a map, whatever you want to call it. For the letter 2, it can be anything of the strings ABC. And then this would be DF. This gets kind of repetitive, but what is it? JHI. And then 5 is JKL. 6 is MNO. 7 is PQRS, 8 is TV, and lastly 9 is WXYZ. You don't need a what is it, comma there. And then we're going to use a Q for this to create our what do you call it? To create our permutations, or actually, is it permutation or combinations? I think it's permutations because the order matters, right? So what we're going to do here is actually do a quick check, because looking at example 2 here, if the string is empty, we want to send an empty array. So what we're going to do is if not digits or length of digits is equal to 0, then we're just going to return an empty list because there's nothing processed there as shown here. So what we're going to do now is q is equal to, you create a deque and q dot append the empty string, just so we're able to create our permutations from the empty string onward. So for number in digits, so for every number we see in the string, if number in mapping, because if we get a 1, then it doesn't matter, right? It's just a random number in there, so we don't care about that. So if number in mapping, then we're going to go into we're going to grab the length, which is equal to the length of the queue, because since we need to create a permutation, for example, when we start with the empty string here and we do 2, we only have this. We can't pop off the empty string 3 times, right? It's just 1. So we have to pop it off once, and we put on a string of A, B, and C, and then we'll do the same thing for 3, and then so like that's how we create the AD, AE, AF, right? So we need the length of the queue here, so that we don't pop off too many items trying to generate these permutations. So for the underscore, because we don't need it, in range of the length, we're going to do popped is equal to q dot pop left. We want to pop off the left because since we're appending to the end of it, we want to pop it off the left. If for some reason you want to append left and pop off from the right, that works too. But I guess logically speaking, in most of code, you append onto the right side. So in this case, we would want to pop off from the left side. So we're going to have popped, and then for character in mapping number, we're going to do q dot append popped plus character, and at the very end we'll just return the queue. So basically, to explain this is, so at the very first instance, running through 23 here, we have the empty string, right? And then we see the letter or the number 2. And so it is in this mapping because 2 is here. Whoops, 2 is here. So now we grab the length of the queue, which is 1, and then for the underscore, because we don't care about this variable, we will go from 0 to whatever number. So 0 to 1, and then, but it's exclusive, so 1 we won't, but we still have 0. So we have to pop off the empty string here. So popped will be equal to, whoops, it would be equal to the empty string here, right? And then so for character in the mapping number, so mapping number will be 2. So we're looping through ABC. And then so we're gonna add the empty string plus A and the empty string plus B, empty string plus C. So then eventually we will have a queue that looks something like A, B, C, right? And then we'll go through again for the 3, and then 3 is in mapping, so we get the length of this, which is 3, and we pop off A first, and then we do AD, AE, AF, and then so we'll push that to the back, so it'll end up looking something like this: AD, AE, AF, right? And we'll do the same thing with B and then C, and that's how we will generate CD, C, CF, stuff like that, right? And so at the very end, once we're all done with the numbers, we can just return this queue, because this queue it could be a type of list. If not, realistically speaking, you can just throw all of the items into a list separately if you wanted to. But in this case, it should work. Let's just do a test run just to make sure. Invalid syntax. See, good thing I did that first, right? So there we go. From collections, we want to import DQ. Okay. Silly syntax mistake. But yeah, as you can see, we generated the list properly. Here for the empty string one, we've returned the empty list properly, and for 2, we've generated ABC. So let's submit this. Hopefully it works. Otherwise, it would look kind of stupid. There we go. 45 milliseconds. It beats 62%. But then the one I did just before, 37 milliseconds, which is the same code as well. I don't think I really did anything different. Yeah. It's 37 milliseconds, which beat 92%. So, honestly, it's more about the time complexity that matters. It's not about the, what do you call it? It's the time complexity that you calculate from here. It's not about this time. This time can vary wildly. Like, I've done 56 milliseconds. But either way, yep, that's the video for today. It's short and simple. Hope you guys like it. See ya.